All right, why don't you try this one, which is number 20 on page 369. See what you get for that. Okay, so in this one, did you factor the denominator? So you have 4x minus 3 over 2x minus 1, x minus 1, and then say that equals a over 2x minus 1 plus b over x minus 1. Did you start it like that? Well, if you did, you wasted your time, because look what you can do instead. Remember I said you should always check first to see, could I use a u substitution? You should always check first to see, could I use a u substitution? U is 2x squared minus 3x plus 1. Du is equal to 4x minus 3 dx, and that's what you've got here. So if you thought to check to use a u substitution, you did it with a u substitution. You did this the most efficient way. And congratulations for spotting that and remembering to look for it. If you did it this way, you're going to get the same answer. It's just a little bit longer trip, and it might be not obvious why it's the same. It's kind of interesting. I don't know how much we'll go into it, but yeah, but if you did it this way, your answer is going to look really different, but it's not, if you understand your log properties. All right, so let's go ahead and do this with the u substitution, because that's much easier. So then we can say that basically we're going to say, where'd my red pen go? Let's not do this. All right, we're going to do instead the integral. We'll just go ahead and do the substitution. It's just u over du. So that equals ln of absolute value of u. And we substitute back our ln of absolute value of 2x squared minus 3x plus 1 plus c. Done. All right, now obviously if I do it this way, I'm going to have a sum of two different logs. All right, do I want to do it? Like, I think it's worth comparing sort of the two ways. So if I did it this way, I would have 4x minus 3 equals a times x minus 1. Obviously, this is going to be much more work. You don't want to do it this way, but just to see, how they compare, because it's interesting to me. So if it's not interesting to you, maybe you should stop watching this video. Maybe I'll stop watching the video. So then I have 4x equals ax plus 2bx, and then so 4 equals a plus 2b, and then negative 3 equals negative a minus b. Very easy to do elimination. 1 equals b. So since 1 equals b, that means that a is 2, right? Yeah, 2 equals a. All right, so then you would say that I have the integral of 4x minus 3 over 2x squared minus 3x plus 1 dx is equal to the integral of, let's see which one goes on top. The a goes on the 2x minus 1. So it's going to be 2 over 2x minus 1 dx plus the integral of 1 over x minus 1 dx. Okay, so then I'm going to get 2 ln absolute value 2x minus 1 times 1/2, because the 2 here. All right, so if I was clever, I could just eliminate that, but I just want to show where it's coming from. Plus, then this one's going to be ln of absolute value of x minus 1. All right, and then these cancel, so I have the 1/2 and the 2 cancel. Ln absolute value 2x minus 1 plus ln of absolute value x minus 1 plus c as soon as I do the integral. So now my question to you is, how do we reconcile these two seemingly different answers to the same problem that came by way of two different methods that are both legitimate? How are they the same? Well, I'll tell you how they're the same. Because the log of AB is equal to the log of A plus the log of B. Doesn't matter what the base of the log is. So that means that this is equal to the ln of the absolute value of 2x minus 1 times x minus 1. And as we already know from the fact that that's how we factored this, that equals the ln of the absolute value of 2x squared minus 3x plus 1 plus c. Now my two answers by two different methods can be shown to be correct. So the only reason I went through this is to show how two apparently very different answers can turn out to be the same if we understand our log properties. But the real moral of the story is check for u and du first, because that's 1,000 times easier than doing all this. Okay, also, by the way, there was a hint, and maybe some of you noticed this, that in the directions, it says find the integral without using the technique of partial fractions. So they're telling you not to use partial fractions. But I wanted us to see why we would do that. Now the next one, number 22, there's more going on in number 22. And so there's sort of another piece of this that we're going to get a chance to look at now. And I do want to look at it. So this is going to be number 2. It's integral of 2x cubed over x squared minus 1 dx. All right, so the first thing we want to check is the numerator the du of the denominator? No, because the denominator is x squared, the du is going to be 2x, not 2x cubed, and there's no reconciling those two. So du, no, we check that, doesn't work. Now if I sit here and start doing partial fractions as this is, you're going to find out it's not going to work. And the reason it's not going to work is the degree of the numerator is higher than the degree of the denominator. So something else you're going to always have to be watching out for is if the degree of the numerator is greater than or equal to the degree of the denominator, then you must do long polynomial division. Okay. You can use synthetic division if the denominator is linear, but and I think for synthetic, it also has to have a coefficient of 1. So how often is that going to happen? This is not a linear denominator, so we can't use synthetic. So in general, we're going to use long polynomial division. See if you remember how to do that. I'm going to do x squared minus 1 divided into 2x cubed. See if you can remember how to do that. I'll put it in the next video.